Here are 4 myths about radiology and AI. The first myth: AI will replace radiologists. Curtis Langlotz, a Stanford radiologist, has said in a Nature article that AI will not replace radiologists, but radiologists who use AI will replace radiologists who don't. AI will be used to enhance the physician's performance. However, it is much more about the unfair advantage the radiologists who know how to use AI will have in comparison with their counterparts. The AI will unlock time for radiologists. With more time on their hands, radiologists will be able to get into the patient interaction and have some clinical knowledge about him. Integrating it with the findings on imaging, their diagnostic will improve. The second myth is that AI can be applied widely, so in different healthcare centers. Firstly, the AI is dependent upon the breadth of the annotated database used. Although there's been extensive problem solving when it comes to restricted annotated databases for imaging, the solution of transfer knowledge has yet to be demonstrated. Transfer knowledge consists of training the algorithm on natural images such as cats and dogs and transferring it afterwards to train it on imaging for radiology. A second problem is represented by the source of the database. For instance, a Mount Sinai team was surprised by the inefficiency in its algorithm when tested in other healthcare centers. The algorithm was meant to identify pneumonia on a chest X-ray. The problem was the use of a local database, namely the database from Mount Sinai. Thus, its accuracy when tested in Mount Sinai conditions was of 90%, but plummeted when tested in other healthcare centers. The last argument that restricts the use of AI in various healthcare settings is the confounding variable. Confounding variables appear when the AI develops features to categorize the diagnosis. In the aforementioned example, people at Mount Sinai found that the algorithm used the odds of having pneumonia at a specific healthcare center in calculating the odds of pneumonia on the chest X-ray. The third myth is about the AI being protected by corporations. Actually, the AI develops its own algorithm to classify and diagnose several images. This deep neural network is what they are calling a black box problem. Neither engineers nor physicians know how it developed. However, there is hope as engineers try to make the code behind it as transparent as possible by making it open access. The fourth myth is that legal issues will be rapidly solved. There are legal issues concerning the approval of such algorithm. FDA would have to run regular check-ins on the algorithm. These neural networks work as humans using Bayesian updates. This means that every time the AI is presented with a new image, it develops new ways of identifying more accurately the diagnosis. To sum it up, the AI learns as it analyzes data. The second issue here is about the conflict between corporations and federal institutions. Most of the companies that are involved in this space prefer to maintain their code open access. However, there are some corporations that prefer to maintain it under the lock. Being forced to be as transparent as possible by regulatory institutions such as FDA will deter companies to enter this market. If you're interested in learning more about machine learning in radiology, check out this Twitter account.